Hello students, so we are now on to 2.3, which is the sine law, the ambiguous case. So the ambiguous case is a really neat, kind of cool thing that occurs in mathematics when you're dealing with the sine law. Now here's your learning outcomes of what you need to know in this video. So recognize when to use the sine law, given a problem, sketch a diagram to represent a problem involving sine law, and then solve problems involving the ambiguous case. So first of all, what the heck is the ambiguous case? Let's kind of just put it in a really simple term. The ambiguous case is when two possible triangles may exist from the given information. So this is a really cool thing that occurs in mathematics. And what you're going to read in your textbook and online is a lot of things to kind of memorize. Some of them have this SSA rule, which is actually pretty useful, or ASA rule. I'm a very visual person, so I actually draw this out to see if the ambiguous case may work. So let's read here just to see. When solving a triangle, you must analyze the given information to determine if solutions exist. If you're given the measures of two angles and one side, ASA, then the triangle is uniquely defined. So in this case, ASA is if you have the side length or an angle, a side length, and an angle. In this case, this triangle has no other option to become another triangle because this angle here that's not given is technically forced to be what's a specific thing, okay? Because this angle and this angle, if you take 180 and subtract these two, that gives you this angle. There's no other option that this can be. Whereas, if you're given two sides and an angle opposite of one of the sides, SSA, the ambiguous case may occur. So if we draw this out, what are they talking about? Well, it's if you're given a side length and a side length, and then an angle. Okay, side angle rule. In this case, what you'll notice is you have this angle that's fixed. But let's see here. What do we not know? I'm going to highlight in red. We do not know this angle, we do not know this angle, and we don't know this side length. So realistically, what could occur is since this is fixed, but these two angles can change, and this side length is not fixed, we could potentially have a triangle that also looks something like this, where this is your side length here. So let's call this S1, S2. This could be S1 as well. So you have two different triangles appearing because these angles can change and this side length is not fixed. It will also change. So the SSA rule is really important. If you have side length angle, you may have the ambiguous case, meaning you might have two different triangles. There's also the potential if you have one triangle and there's one solution. When does this occur? This occurs if you have a right triangle. So if you're given a side length angle, one triangle might occur, but it's only in a specific region. That's if you have a right triangle being formed. So we're given this side length, we're given this side length, and then we're given this angle. That's if this height just is able to touch and you form a 90-degree angle. So that is your right triangle rule. This here, the two triangles, that's above here. And if there's no solution, when does that occur? Let's draw that over here. That will occur as if you're given a side length. So I'm going to actually draw these separately here. A side length and a side length. And then you're given an angle. So angle A. Side length 1, side length 2. So this occurs if there's no solution, because if this leg, this side length that's given, is too short and it's not able to reach. So you have two solutions if the side length is big enough to reach, and you can actually swing it across and form another triangle. You have one solution if you create a 90 degree. And if you have too short of a leg given, where it won't actually touch the unknown side length. So you have a few different possibilities that occur. So let's check this out. So say you're given the following problem to solve. If an angle equals 44, side length is 11, and side length A is 8, determine the measures of the other side and angles. Is there more than one triangle that can be formed using these dimensions? Start with what we're given. So here we're drawing out what we know. Again, we don't know this angle or this angle, and we don't know this side length we know this side length here. It's 8. The thing is 8 long enough to interact with the unknown length here? So in this case, you have two triangles that you will look like. So you have an acute triangle here, and you have another triangle here. So it looks like you have two triangles that can be formed. Okay, you have an acute triangle, so it's smaller. Let's define that, smaller than 90 degrees. And an obtuse triangle, which is larger than 90 degrees. Now, oftentimes people get confused on how to find the other angle. Recognize in this case, I'm going to try and draw this out the best of my ability. It looks like it's more like that. Okay, there we go. So we have 11, 8, and 44. If we consider the other triangle that can be formed, and we bring it down here, and this is 8. So you have the two triangles. So this triangle here is found right here. Okay, and this triangle right here is found right here. Now, if we're able to find this angle, let's just call this angle 1. You can easily find this angle using a bit of understanding of triangles. Recognize this is an isosceles triangle. This has the same side length as this. So that automatically makes this angle 1. And then recognize this is 180 degrees. A straight line forms 180 degrees with itself. So you could easily form this angle, angle 2, by doing 180 minus angle 1. And oftentimes you can find angle 1 fairly easily. So again, you're going to get introduced to a bunch of different rules. You're going to get introduced to a bunch of different laws. Those can be very confusing. If that works for you, that's awesome. But I'm a visual person. I always draw it out first, and the first thing I try and find is that unknown angle that is attached to my known length and my unknown length. If it forms an error, you automatically know that there is no triangle. If it forms an angle that is not 90 degrees, then you have an ambiguous case. And if it forms 90 degrees, then you have one case. So let's see some examples here. So example 1, in ABC, so triangle ABC, angle A equals 30 degrees, A is 24 centimeters, and B is 42. Determine the measure of the other side angles. Round to the nearest unit. So the first thing we're going to do is draw it out. So we're going to draw out an arbitrary looking triangle. We're going to notate it A, B, and C. And now angle A is 30 degrees. Side length A, which is opposite here of angle A, is 24 centimeters. And angle B here is 42 centimeters. Now, this is a little trick or a tip for yourself here. Look at this and ask yourself, do I have angle, side angle? You do, side angle. So you do have the ambiguous case forming. Now again, what's the first angle we should try and find? We're going to try and find the angle that is attached to the unknown side length and the given side length. Right now, we don't even know if this side length here is long enough to form a triangle. We've just drawn one to assume that it might work. So recognize two outcomes, one acute triangle and one obtuse triangle. So let's draw this out. Let's first redraw this and ask ourselves, what do we know? So this is 30 again. This is 42. This is 24. A and B. So this would be little c here. So the first thing I'm going to do is I'm always going to, again, for an ambiguous case, always determine angle formed from unknown side length and known side length. And again, why is that? That's because if you get an error in your calculator, error equals no solution. That means that this side length is too short. You may also get an angle not equal to 90 degrees. This means you're dealing with the ambiguous case, and you have two solutions. And lastly, what's the last step or last possible outcome? The angle equals 90 degrees. This means you have one solution. And remember, you only have to do this if you have the side length angle occurring. Okay. So now in this case, let's find B then. So first, find angle B. So my first step is to find angle B. Now, angle B here, we can solve using our sine ratios. So again, you would have your formula sheet. Should probably go grab that. Just got to edit this quickly. Oop. There we go. Okay, so we're going to bring down our formula sheet. Let's move this over quickly. There we go. So let's bring down our formula sheet. And we're still going to use the sine laws here. So our sine laws, if we look here, again, how to use the sine law? You find a side length and the opposing angle. Side length, opposing angle. So in this case, we're trying to find B. So I'm going to write sine B on the top. The corresponding length to sine B is 42. And now what can we use? Well, we can use this angle and its opposing side length. So this will be sine 30 over 24. And now we can solve for the angle of B. So I'm going to multiply 42 by both sides. And I will get sine B equaling sine 30 over 24 times 42. So this will become sine 30 times 42 divided by 24. So that gives me 0.875. And now in this case, what do? Well, we take the inverse of both sides to solve for that angle. So angle B is going to equal the inverse sine 0.875. And there we go. We got an angle here. We got an acute angle, 61.0449 degrees. So there is our first angle. So we definitely have two solutions. So in this case, this is an angle not equal to 90 degrees. So we have two solutions, aka two possible triangles. So let's draw out both these triangles here. Just going to move this down here. Okay, let's draw out both these triangles. So we already have one of the triangles written. This would be your angle smaller than 90 degrees, 61 degrees here. But now you have another possibility, the other triangle. And what will the other triangle look like? The other triangle is as if we took this side length and we brought it all the way over here. So the triangle is going to look a little weird, but it'll look something like this. So try and draw it as accurately as I can. There we go. So it'll look something like this, where I'm going to notate this as A, C, and B. This is still angle 30. This is still 42, because this is B. This is still 24 centimeters. But now our angle B is a little different, because originally, let's draw the triangle that we just found. If we extend this out, you can kind of see the triangle that we just found up above. This is 24 here. Here was our 61 degrees. Now, we want to determine the obtuse angle here. So this is our other possibility. I'm going to call this angle 2. You can find angle 2 by doing 180 minus 61 degrees. And why does that work? Because again, this is an isosceles triangle here. Since this is an isosceles triangle, this angle is equal to this angle. So 180 minus 61. So that gives me 119 degrees. And now you can see we have two different triangles. You have one triangle and you have another triangle. Therefore, we have our our ambiguous case. So it wants us to determine all the other measures. So in this case, we are going to find all other measures. So I'm going to focus on this one first and then focus on the other one next. So for triangle 1, we're nearly done. We can find angle C now by just recognizing that we have two angles for a given triangle, so I can subtract them from 180. And what is that going to give us? 180 minus 61 minus 30, so that gives us 89 degrees. So this will be 89 degrees here. And finally, we want to solve for C. How are we going to do that? Well, we're trying to find a side length. We're going to use the sine ratios. So C over sine C equals, in this case, we want to use an angle given with an opposite side length. So A over sine A. And now it's a matter of plugging in properly. So C over sine C, which was 89, equals A, which is 24, over sine A, which is sine 30. And now it's a matter of plugging in and calculating properly. So multiply both sides by sine 89. cancels out, and we get C equaling 24 times sine 89 over sine 30. So in this case, we'll get 24 sine 89 divided by sine 30. So that gives us, we're going to round that to 48 centimeters. So now we have solved all about this triangle. But remember, we have two solutions. So let's go over here and solve this triangle now. So we found angle B to be 119 degrees. We can now find this angle. So find angle C, which will be 180 minus our known. So 180 minus 119 minus 30. Let's check what that gives me. So 180 minus 119 minus 30. So that gives me 31 degrees. So we almost have an isosceles triangle here. And now we have enough to solve for our unknown length of angle C. Or sorry, side length C. So this we said was 31 degrees. This is 119 degrees. Now we're going to solve for C. So find C. And we will have C over sine C equals, and again, use the side lengths given. So A over sine A. So this will become C, which is what we're solving for, over sine C, sine 31, equals A, which is 24, over sine A, which is 30. So A, which is 24, sine A, which is 30. And now we will hopefully be able to solve for this pretty easily. 24 times sine 31 over sine 30. And that's going to give us 24 times sine 31 over sine 30. And that gives us 24.721 centimeters. So we have quite a bit of different solutions. We're going to round that to 25 centimeters. So let's list everything here. So let's list our final result. So due to the ambiguous case, we have multiple answers. So angle C, we found to either be 89 degrees or 31 degrees. And then we have angle B, we found to either be 61 degrees or 119 degrees. And then side length C, we found to either be 48 centimeters or 25 centimeters. And there's our final answer. So if that was at all confusing, that's okay. The ambiguous case is probably one of the harder things to kind of wrap your head around and get to know. The biggest thing is being visual with it. Pretending to swing the arm that you can move around and visually seeing if it could become two different triangles, if it can become only one, or if there has absolutely no solution because it's just not long enough. So at this point, take a break. I would suggest maybe going and practicing a question or two about the ambiguous case and then coming back to the video. So here is everything kind of laid out for you. This is found in your textbook. And this is what I mean by all of the memorize-y stuff. Again, the biggest thing is solving for that unknown angle that's attached to the unknown side length and side length. Because again, if there's no solution, that means you have no angle, meaning you have no triangle. And that's because the side length that's unknown is just too short, okay? And here you can state it in terms of like A is smaller than H, and A is smaller than B sine angle, which is also known as H there. So that is what we're talking about. This is just too small, and you can see it just kind of swinging there. It can't connect. Here is where you have that 90-degree angle being formed by A. So if you find it's 90 degrees, then you have a single solution. Because if you swing this anymore, it's going to go up. If you swing this anymore, it's going to go up. So you just have one solution. And then as soon as you find that you have an angle, that means you therefore have a solution. Okay, so here we can see this angle swings around and forms another angle over here. And you can see that we have an isosceles triangle being formed here when you swing it around. Due to that isosceles triangle, whatever angle is found here, you can use to solve the other angle. Okay, so if we call this angle 1, this angle 2, angle 2 will be equal to 180 minus angle 1. So you can find those two here. So please go give this a shot. Come in and ask lots of questions. If you're really confused, then we can just do a few practice problems together. No issue at all. So give it a shot. Try and find examples that go through all the different possibilities. Again, follow this kind of method. As soon as you have an SSA situation, determine the angle formed from the unknown side length and known side length. If your calculator gives you an error, there's just no solution. If you have an angle that's not 90 degrees, you have two solutions, so figure out both triangles. If your angle equals 90, you therefore have one solution. I hope that helped. If you have any questions, please come ask. Other than that, have a great day.